morning, everyone. My name is Chen Jieqing. I'm responsible for the infrastructure development here at TigerGraph. Today, I will present one of the TigerGraph's new offerings for version 3.2 that supports running TigerGraph on Kubernetes. Later, my colleague Wenbing Sun will give a demo on how to do that in practice. Now, let's get started. So what is Kubernetes? Kubernetes is a container orchestration system which provides ways for people to automate application deployments, scaling, and management. The application deployment has gone through several phases for the past decades. Initially, each company has their own managed cluster setups in-house, and the applications typically runs in their in-house bare metal clusters. Over the past few years, we've seen a big trend of transitioning to deploying applications on the cloud. And these applications are running on the virtual machines that are created by cloud vendors. Nowadays, we're seeing a new trend where people are deploying applications on container runtime. And Kubernetes is de facto container runtime management system, which can manage the container runtime in a cluster. The container runtimes are typically more lightweight compared with hypervisors, and you will have a much more replicatable environment compared with the virtual machines. Now, before I talk about how do we do Kubernetes deployments for TigerGraph, let's first look at how do we deploy TigerGraph without Kubernetes. Nowadays, if you deploy TigerGraph on bare metal clusters, you can run it as different partitions. Each partition contains a subset of the graph data, and they will run as a separate database instance on one of the physical nodes that we deploy to. On the figure here, you will see there are 3 nodes, and each of the nodes is running one of the database instances. Now, let's take a look at what is the difference in the Kubernetes deployments. In Kubernetes, there's this new concept called pods. The pods are the smallest deployment units in Kubernetes. And one pod is essentially one container. Now, each node can run one or many pods, and each of the TigerGraph database instance are running within these pods. So now, instead of running in the actual node, we are running one of the TigerGraph instance in one pod. In this case, database instance 0 and instance 1 are running on pod 1 and pod 2, which runs on node 1. And database instance 2 runs on pod 3, which runs on pod 2, node 2. So with this setup, you can actually run more database instances than the physical node you have. Now, this is the supported, this is the overall architecture of TigerGraph on Kubernetes. In the middle, TigerGraph database instances are running as stateful sets. Stateful sets is one concept in Kubernetes where the pods are associated with what we call the persistent volumes. Persistent volumes are physical disks that the database instance storing the data to. In this case, you will see when you have multiple database instances, each of the database instances will have a corresponding persistent volume claims, which associated with one of the persistent volumes. And this is where the actual graph data is stored. On the left-hand side, you will see the TigerGraph services and APIs are exposed to external users through Kubernetes services. Kubernetes services provide a set of fixed domain services to the external APIs, so the users can access TigerGraph services through these fixed domains without needing to connect to the actual pods. Underneath, you will also see a bunch of other components which we use to set up the cluster, manage the configurations, and the user secrets of the cluster. Here is a list of supported features of TigerGraph on Kubernetes in our 3.2 release. First of all, we are supporting single command deployments. My colleague Wenbing Sun will give a demo later on how to actually do that. The second feature is we are supporting cluster deployments. In the old releases, we had a support for supporting single node Kubernetes deployments, and in 3.2, we are releasing the cluster deployment. The third feature is disaster auto healing. The disaster here means you might have a pod failures, or you might have a node failure, or you might have a database instance failures. All of these failures can be handled automatically, and Kubernetes will spin up a new pod with the corresponding persistent volume claims to recover the database system. Next feature is we're supporting out-of-box load balancing. As you saw in the previous figures, we are adding another layer of service in front of the TigerGraph pods. So that layer provides the load balancing functionalities on top of TigerGraph. And that's something you didn't get when you were deploying that on the bare metal deployments. Last but not least, we are supporting customizing your deployment manifest. Some of the important configurations are replication factors, which controls what is the number of replicas we are running for the database instance. You can see the actual details of how to run TigerGraph on Kubernetes here in the below link. And the support for Kubernetes works for all three major cloud vendors. That is for EKS from Amazon, GKE from Google Cloud, and AKS from Microsoft Azure. So these different cloud vendors can be specified when you're setting up your Kubernetes manifest. With that, I will give that to my colleague Wenbing Sun to give a demo on how to actually deploy TigerGraph on Kubernetes.
Hello everyone, my name is Wenbing Sun. So next, I will demonstrate how to run TigerGraph quickly inside Kubernetes. In today's demo, we have three objectives. Firstly, we'll deploy a 3 nodes TigerGraph cluster in GKE. After deployment, we'll do some basic function tests with this new cluster to make sure everything is running properly. After that, we'll do a node failover test to ensure our cluster can be auto-recovered, even if 1 node or several nodes were down. We'll follow the deployment guide as below. So if you go to our website from the TigerGraph documents, and you choose 3.2, from the left side, you will find some new documents just for Kubernetes. As you know, since 3.2, we have fully support TigerGraph deployments for single server or several nodes in Kubernetes in different environments. So basically here we provide the quick guide how to deploy TigerGraph inside those environments. So if you got a chance to play TigerGraph in those environments, please take a look these documents first. Then you can easily deploy the TigerGraph there. So today we will use this quick start with GKE to deploy a cluster. Let's open it. Basically, this is a quick start guide for deploying TigerGraph on Kubernetes within GKE for single server or class deployment. For today's demo, we will use the class deployment. Before the actual deployment, we need to make sure that we have running GKE cluster with nodes that meet the minimum hardware and software requirements for TigerGraph. So make sure that your nodes have enough vCPU memory and disk for TigerGraph. So other than you need a kubectl command line tools to be installed in your local machine. And you also need the IAM role for a GKE cluster so that kubectl can get access to that cluster. For cluster deployment, we have several steps as below. Firstly, we need to generate a Kubernetes manifest. To do that, we need to clone the repo from our TigerGraph ecosystem as below. After the download that code, you can check that the deployment code from below fold. After you created the manifest, we can deploy them faster to GKE. And the next step, you can verify the cluster status with below command. And then you can connect to our instance or connect to our Graph Studio. Next, let's go to our demo environment. Here, as you can see, for this demo, I have opened two terminals which is connected to my local Linux box. Inside this Linux box, I have installed kubectl in advance, and I can connect to my GKE cluster without any problem. And from here, you can see for this cluster, we have 3 nodes inside. And for each node, we have 16 CPU and 64 qubit memory. So that's enough for 3 nodes deployment for TigerGraph. So next, I will follow the guide to do that deployment. So first step, we need to clone this repo. Because this repo is a little big, so I already cloned it before this demo. It's inside this fold. So let's cd to this fold. As you can see here, this is the whole structure of our development code. Our main development code for TigerGraph was inside in the base fold. As you can see here, all the components used by TigerGraph have the YAML file here, such as config map, service, step-set, installer. And the customization file will finally combine all those YAML files to a single deployment manifest, which will saved in the deploy fold. For AKS, EKS, and GKE fold, which is just used for the dedicated cloud environment. So there's some special settings only works for this environment. So we have some patch here. So other than that, we have the doc file, which you can use to build a Docker image for yourself. But as you know, we have a dedicated, Kubernetes Docker image in our Docker registry, so you don't have to do that. After that, we have also provided a TigerGraph, which can be used to customize the final manifest. So let's check the help. So as you can see here, with this TigerGraph, you can do customize, you can create, delete, list, the cluster in GKE, and also you can change some common settings like a namespace, size, license, PVHA prefix to the final manifest. So we will use TigerGraph to do this deployment today. So next, I'm going to first generate the manifest as below command. So size, we choose 3, version, we choose 3.2.0, and I want the port to have a name with TG demo. Okay, now from the deploy fold, you will find some new file here, which is the finally deploy manifest for TigerGraph in GKE. So let's have a quick look for this YAML file. This is actually the final deployment YAML file, which is combine all the components which are used by TigerGraph in Kubernetes. As you can see, we have storage class, we have different config map here, and we also have service, different 2 service, one headless service, one external service, and we also have step set as here. As you see, we specify the replica as 3. So we will create 3 instances for TigerGraph, and the type name should be started with TG demo, and also we specify the vision here. So it will actually change the Docker image from here. So yeah, that's the final deployment. Let's apply it. Great. You can see Kubectl control will help to create all those components for TigerGraph inside Kubernetes. A storage class, 2 config map, service, and step set and job installer. So let's have a quick look for the ports. So as you can see, now 1 port already created. It's running. Another one is creating now. If you try from your own Kubernetes, the first time maybe you will slow because it's need to download the TigerGraph image from remote. So it might take some time. After the download, the next time you install the cluster, it should be much faster. So as you can see here, for all 3 instances now, it's running now. Each one take around 20 minutes to spin up. So after that, our installer here will start running. It will basically waiting all the service run, all the TigerGraph instance running, and the DNS for each instance was updated in Kubernetes DNS. So then we'll check the cluster installation. So now it's running. I believe it's started initialize the whole cluster. It will change the single node instance of TigerGraph to a cluster of TigerGraph. The installer will take around 1 minute to 2 minutes to to finish the changing. This installer now is completed. So as you can see here, the installer now is completed. So now I think our cluster is ready to use. Let's first check the logs of the installer. Make sure the installer is complete. As you can see here, the installer instance SH to our TigerGraph instance, and then from there it will kick off the initialize of the cluster. As you can see here, the cluster is initialized successfully. Okay, next let's check the service. All right, as you can see here, we can find the external IP address for our Graph Studio and API service. Let's have a quick check for our API service. Okay, we get the response, a message, hello Cisco. That means the API is up. And let's have a quick look for the Graph Studio. Okay, we can access our Graph Studio now. So that means our application is running. We can see the status from our cluster. We have 3 nodes. Our service was running properly. Okay, that's great. So next, let's check the status inside the TigerGraph instance. Okay, let's use -min status -b. As you can see, all status were running properly. And let's check the physical status. Yeah, we can see that currently it's empty. There's no data inside, but the service is running properly. So next, let's load some data. Firstly, let me copy some data inside the TigerGraph. It will restart the service. After then it will load the data. Great. The data was loaded. Now let's do some basic query. So the query is successful. As you can see here, we are trying to find all friendship edge whose source vertex is Tom. So the first one is Dan. So that means the service is running properly. We can starting loading the job. We can loading data and do the query. So everything is looking fine. Okay, next let's implement the final failover test for our cluster. We have 3 nodes cluster. So in this test, I will manually delete 1 node and let's see what will happen. So before the test, I would like to running a script which will keep calling our service and check the status of our service. So basically, this script will call our M1 and M2 and keep querying Tom's friendship, and which will respond to the first friend of Tom, which was Dan. So if the call is successful, it will show Dan. If it is failed, it will show failed. So then let's keep running. So now as you can see, every service is running properly. So we get the Dan here. Okay, we're ready to delete the pods. So let me delete the pod now. So we will delete M2 for this cluster. Okay, as you can see now, the port was deleted. So let's see the status right now. Okay, it's very quick. So this one was recreated. Kubernetes recreated the field instance again. So we got this instance back again. But as you can see from here, our cluster now is failed. Our API stopped work. So it's because when the new instance is up, it will start reinitialize the whole cluster. So during this period, all the code maybe will failed. So let's wait a few minutes. Normally, this failover will be auto recovered in 2 minutes. It's still ongoing. Great. As you can see now, we got the response back again, and as you can see, the result we got the first friend of is 10. So that means the service is recovered, and all data was keeping. So we didn't lose any data. Even one node was failed. Okay. So the failover is done. That's pretty much my demo today. If you have any other questions, just let us know.